On March 7, 1944, at 0830 hours, Vice Admiral Jisaburo Ozawa stood on the bridge of the aircraft carrier Taiho, watching the morning sun rise over Linga Road's anchorage off Sumatra. The ship beneath his feet represented 32 months of labor, 16,000 tons of steel, and the entire remaining hope of the Imperial Japanese Navy. Taiho was the only purpose-built fleet carrier Japan had commissioned since the war began. One carrier, in 32 months. Ozawa had received intelligence reports 3 days earlier. The Americans had commissioned 17 new fleet carriers in that same period, 17. And they had stopped counting the smaller ones. The numbers made no sense. They violated everything Ozawa understood about industrial capacity, shipyard limitations, and construction timelines. Japan had spent decades building the finest carrier force in the world. The Americans had supposedly started from nothing. Yet somehow, in less time than it took Japan to build one Taiho, American shipyards were launching new carriers every month. Ozawa knew what those numbers meant. They meant Japan had already lost the war. The shooting would continue for another 16 months. Thousands more men would die. But the outcome was decided by mathematics, steel, and welding torches in shipyards 7,000 miles away. The question that kept Ozawa awake at night was simple. How did they do it? Japan entered the war with the most powerful carrier force ever assembled. 6 fleet carriers, 2 light carriers, all modern, all battle-tested. The American Pacific Fleet had 4 carriers. Japan had numerical superiority, tactical superiority, and 2 decades of carrier doctrine development. The Japanese Navy had been building carriers since 1922. They understood carrier operations better than any navy in the world. Their pilots were the best trained, their aircraft were proven in combat, their tactics were refined. Through years of war in China, American carriers were untested, American pilots were inexperienced, American doctrine was theoretical. On paper, Japan should have dominated carrier warfare for years, but paper lies. By December 1941, Japan knew it faced a fundamental problem. The United States had an industrial capacity 10 times larger than Japan's. Raw steel production, shipyard capacity, machine tool manufacturing. Everything favored America by ratios that seemed impossible to overcome. Admiral Isoroku Yamamoto understood this better than anyone in the Japanese High Command. He had served as a naval attaché in Washington. He had seen American factories, American shipyards, American industrial infrastructure. He told the Japanese government that Japan could win battles for 6 months, perhaps a year. After that, American industrial power would overwhelm anything Japan could produce. The government ignored him. They believed spirit could overcome steel. They believed tactical brilliance could defeat numerical superiority. They believed Japan's warrior culture gave them an advantage that factories could not match. They were wrong. The first carrier Japan lost was Shoho, sunk on May 7, 1942, during the Battle of the Coral Sea. She went down after taking 13 bomb hits and 7 torpedo strikes from American carrier aircraft. Shoho was a light carrier, 11,000 tons, converted from a submarine tender. She carried 30 aircraft. Her loss was significant but not catastrophic. 1 month later, Japan lost 4 fleet carriers in a single day at Midway. Akagi, Kaga, Soryu, Hiryu, gone. Sunk by American dive bombers in a battle that lasted 6 minutes. Those 4 carriers represented 20 years of Japanese naval development, 40,000 tons of irreplaceable combat power, and 250 aircraft. The Japanese naval staff in Tokyo received the reports and immediately began calculating replacement timelines. Akagi had taken 4 years to build. Kaga had taken 6 years. Soryu took 3 years. Hiryu took 4 years. Average construction time, 4¼ years per fleet carrier. 4 ships lost. 17 years of construction time to replace them. Japan had 3 major shipyards capable of building fleet carriers: Yokosuka Naval Arsenal, Kure Naval Arsenal, and Kawasaki Shipyard in Kobe. All three were working at maximum capacity building destroyers, cruisers, submarines, and merchant ships to replace combat losses and support offensive operations. To replace 4 carriers would require dedicating all 3 yards to carrier construction exclusively for nearly 6 years. That meant no destroyers, no cruisers, no submarines, no merchant ships. Japan could not afford that. The war required everything. The naval staff made a decision. They would build 1 new fleet carrier, Taiho, which had been laid down before Pearl Harbor. They would convert merchant ships and seaplane tenders to light carriers. They would design a new class of smaller, cheaper carriers that could be built faster. The plan looked reasonable on paper. Taiho would provide fleet carrier capability. The conversions would provide interim replacements. The new Unryu-class carriers would eventually restore Japan's numerical strength. It was a logical plan, carefully calculated, properly resourced. It failed completely. Taiho's keel had been laid on July 10, 1941. The ship was launched on April 7, 1943. She was commissioned on March 7, 1944, 32 months from keel laying to commissioning. That was actually fast for a Japanese fleet carrier. Shokaku and Zuikaku, laid down in late 1937, had taken 44 months and 45 months respectively. Japan had improved its carrier construction timelines significantly. 32 months was an achievement worth noting. The Americans commissioned USS Essex on December 31, 1942. Her keel had been laid on April 28, 1941, 20 months. The Essex was larger than Taiho. She displaced 27,100 tons, standard compared to Taiho's 29,300 tons. She carried 90 aircraft compared to Taiho's 75, 20 months. The Americans had built a larger, more capable carrier in 37% less time than Japan's fastest construction program. But that wasn't the shocking part. The shocking part was that Essex was just the first. In January 1943, Lexington was commissioned, then Yorktown, then Bunker Hill, then Intrepid, then Hornet, then Franklin. By December 1943, the Americans had commissioned 11 Essex-class carriers, 11. In 1 year, Japan commissioned Taiho, 1 carrier. In 1944, the naval staff in Tokyo studied the intelligence reports. They checked the numbers, repeatedly. They assumed American propaganda was inflating production figures. But reconnaissance aircraft confirmed it. Photographic intelligence confirmed it. Intercepted radio traffic confirmed it. The Americans were launching carriers faster than Japan could train pilots to fly from them. How? The answer started with a man named Henry Kaiser. Kaiser had never built a ship in his life before 1941. He was a construction engineer. He built dams, roads, bridges, the Hoover Dam, the Bonneville Dam, the Grand Coulee Dam, massive concrete structures that required moving mountains of material and coordinating thousands of workers. In 1941, the United States Maritime Commission needed cargo ships. Hundreds of cargo ships. Thousands of cargo ships. Ships to carry food, fuel, ammunition, tanks, aircraft, troops across the Atlantic and Pacific. Traditional shipyards said it would take 6 months to build a cargo ship. That was normal. That was how shipbuilding worked. You laid a keel, built up from the bottom, riveted steel plates together, installed engines, launched the hull, then spent months finishing the interior, 6 months per ship. The Maritime Commission needed 2,000 ships. That would take 1,000 years of shipyard capacity. Kaiser looked at the problem differently. He didn't see ships. He saw structures. Steel structures that could be broken down into components, prefabricated in separate facilities, then assembled at the shipyard. Instead of building ships from the bottom up, one piece at a time, Kaiser proposed building ships from sections welded together. Traditional shipbuilders said it was impossible. Riveting was proven technology. Welding was risky. Welded seams could fail. Cracks could propagate through welds and break a ship in half. Kaiser said he would take the risk. He built 4 shipyards in Richmond, California, on San Francisco Bay. He hired workers from across the country. Most had never seen a ship before. Many were women. Many were African Americans who had been excluded from shipyard work. Kaiser didn't care about experience. He cared about organization. He divided ship construction into modules. Each module was built in a separate prefabrication shop. Deck sections, bulkheads, engine rooms, superstructures, everything broken down into pieces that could be built by workers who only needed to know how to weld that specific piece. The modules were built on their sides or upside down, whatever orientation made welding easiest. They were moved to the shipway with massive cranes, lowered into position, welded together. The first Liberty ship Kaiser built took 196 days. The 10th took 45 days. By 1943, Kaiser's yards were completing Liberty ships in an average of 42 days. The record was 4 days, 15 hours, and 29 minutes. The SS Robert E. Peary, built in November 1942 as a publicity stunt to demonstrate what was possible. 4 days, to build a ship. Traditional shipbuilders had said 6 months. The technique worked for cargo ships. Could it work for carriers? Kaiser proposed converting his methods to escort carrier production. Small carriers, built on merchant ship hulls, designed for convoy protection and ground support rather than fleet actions. The Navy was skeptical. Carriers were complex. They required specialized equipment, trained workers, years of expertise. Kaiser said, give him a chance. His Vancouver, Washington shipyard laid the keel for the escort carrier Casablanca on November 3, 1942. The ship was launched on April 5, 1943. Commissioned on July 8, 1943. 8 months from keel to commissioning. The Navy wanted 50 escort carriers. Kaiser delivered 50 carriers in 14 months, 1 carrier every 8 days. The Japanese naval staff in Tokyo received these reports and assumed they were errors. 1 carrier every 8 days was physically impossible. It violated every principle of naval construction. But the reports kept coming, and they were confirmed by combat encounters. By late 1943, American carrier task forces were appearing in the Pacific with numbers that made no tactical sense. 12 carriers, 15 carriers, 18 carriers in a single task force. Japan's entire carrier strength was 6 ships. The Americans were deploying task forces larger than Japan's entire carrier fleet. Where were these ships coming from? Not just Kaiser's escort carriers. The Essex-class fleet carriers were arriving in squadron strength. The secret was the same prefabrication technique applied to fleet carrier construction. Newport News Shipbuilding in Virginia had been building carriers since the 1930s. They knew carrier construction. They knew it took years. But they learned from Kaiser's cargo ship methods. They started prefabricating carrier components. Hull sections, hangar decks, flight decks, island superstructures, all built in separate shops, then moved to the shipway for final assembly. They replaced riveting with welding wherever possible. Welding was faster, required less skilled labor, created lighter structures. They standardized designs. Every Essex-class carrier used the same plans, the same components, the same equipment. Workers learned to build one module, then built dozens of identical modules. They streamlined construction sequences. Instead of waiting for one section to be completed before starting the next, multiple sections were built simultaneously in different locations, then brought together. USS Franklin, built at Newport News, was laid down on December 7, 1942. Launched on October 14, 1943. Commissioned on January 31, 1944. 13 months from keel to commissioning. That wasn't even the record. Several Essex-class carriers were completed in 14 to 16 months. The average was 18 months. Japan's Taiho took 32 months. American shipyards were building fleet carriers twice as fast as Japanese shipyards, and they were building more than twice as many. By the time Taiho was commissioned in March 1944, the Americans had 17 Essex-class carriers in service or under construction, 17 to 1. The ratio was worse when you included the light carriers and escort carriers. America was operating more than 100 carriers of all types by mid-1944. Japan had 9. The Japanese Navy tried to adapt. They ordered 14 Unryu-class carriers. These were smaller than Taiho, simpler to build, designed for mass production. The Unryu class was based on the pre-war Hiryu design, modernized but using proven technology and standard components. They displaced 17,150 tons, carried 5 aircraft, could make 34 knots. They were supposed to be Japan's answer to the Essex class. 3 were completed: Unryu, Amagi, Katsuragi. Unryu was commissioned on August 6, 1944, Amagi on August 10, 1944, Katsuragi on October 15, 1944. 3 carriers, commissioned within 10 weeks. It seemed like progress. Japan was accelerating carrier production, except the Americans commissioned 9 Essex-class carriers in the same 10-week period. The Japanese couldn't catch up. Every time they accelerated production, the Americans accelerated faster. Worse, Japan was running out of resources. Building a carrier requires steel. Lots of steel. An Essex-class carrier contained approximately 27,000 tons of steel plate, structural steel, armor plate. The United States produced 60 million tons of steel in 1943, 80 million tons in 1944. Japan produced 8,004,000 tons in 1943, 6 million tons in 1944. The American steel industry was producing 10 times more steel than Japan's entire industrial capacity. That steel gap rippled through every aspect of naval construction. American shipyards had steel. They could build hulls, armor, machinery, everything they needed. If a section was damaged or incorrectly built, they scrapped it and built a new one. Japanese shipyards rationed steel. Every plate was precious. Mistakes had to be fixed, not replaced. Construction slowed because workers spent time repairing errors instead of moving forward. American shipyards had machine tools, lathes, drill presses, milling machines, all modern, all powered, capable of precision work at high speed. Japanese shipyards rationed machine tools. Many were old, worn out, breaking down. Replacement parts were scarce. Production slowed because machinery failed and workers waited for repairs. American shipyards had welding equipment, thousands of welding stations, oxygen acetylene torches, electric arc welders, all standardized, all maintained. Japanese shipyards rationed welding equipment. Many yards still relied on riveting because they lacked sufficient welding capacity. The gap extended to trained workers. American shipyards employed 2 million workers by 1943. Many were new to shipbuilding, but they were trained quickly using standardized methods and simple repetitive tasks. Kaiser's Richmond shipyards alone employed 90,000 workers at peak production. That was more workers than all 3 of Japan's major naval shipyards combined. The Richmond workforce looked nothing like traditional shipyard crews. 40% were women. Many had never held industrial jobs before. They were farm wives from the Midwest, teachers from rural towns, office workers from cities across America. They learned to weld in 2 weeks of training. They learned to operate cranes in 3 days. They learned to read blueprints in a week. Traditional shipbuilders said these workers couldn't possibly build quality ships. They lacked the years of experience required for precision metalwork. But Kaiser's prefabrication system didn't require years of experience. It required workers who could do one specific task repeatedly and accurately. A welder in the Richmond yards didn't need to understand ship architecture. She needed to know how to weld a specific type of seam on a specific type of joint. The blueprints told her where. The jigs and fixtures held everything in position. She moved from one piece to the next, welding identical joints dozens of times per shift. Repetition created expertise. After a month, workers became fast. After 2 months, they became precise. After 3 months, they could work faster than traditional shipwrights who had spent years learning their trade. The Japanese couldn't replicate this model. Japanese shipyards employed 300,000 workers. Many were skilled craftsmen, but they were spread thin across dozens of projects. Training new workers was slow because experienced workers were too busy to teach. More critically, Japanese industrial culture emphasized craftsmanship over standardization. A skilled Japanese shipfitter took pride in custom fitting each piece, making minor adjustments to ensure perfect alignment. That approach produced beautiful ships, but it was slow. American workers didn't custom fit anything. Parts were manufactured to precise specifications in prefabrication shops. They either fit together or they didn't. If a part didn't fit, it was rejected and a new one was made. That approach produced functional ships. Fast. The difference in philosophy reflected the difference in industrial capacity. Japan had limited steel, limited machine tools, limited workers. Every piece had to be used. Waste was unacceptable. Custom fitting ensured nothing was wasted. America had abundant steel, abundant machine tools, abundant workers. If a piece was wrong, they made another one. Speed mattered more than perfection. Both approaches had merit, but in wartime, speed won. The Americans had enough workers that they could specialize. One crew built bulkheads, another crew built deck sections, another crew installed propulsion machinery. Specialization increased speed. Japanese shipyards needed workers who could do everything. Shipfitters had to fit hulls, install machinery, run electrical systems. Generalists were flexible but slower. Newport News Shipbuilding, the yard that built most Essex-class carriers, developed specialized assembly areas for different carrier components. One building, 500 feet long, was dedicated entirely to fabricating flight deck sections. Giant overhead cranes moved steel plate from storage racks to cutting stations where workers with acetylene torches cut the plates to specifications. The cut plates moved to edge preparation stations where workers beveled the edges for welding, then to assembly jigs where the plates were aligned and tack welded together. Finally, to welding stations where teams of welders completed the permanent welds, working in sequence, each welder responsible for a specific section. A complete flight deck section, 120 feet long by 90 feet wide, took 8 days from raw steel to finished component. That same section, built using traditional methods with a single crew working in the shipway, would take 6 weeks. Another building fabricated elevator assemblies. Carrier elevators were complex mechanisms, hydraulically powered, capable of lifting 30-ton aircraft from the hangar deck to the flight deck in 30 seconds. Traditional shipyards installed elevators piece by piece